In problem 7, 8, and 9 of homework 9, we're testing hypotheses involving proportions. When doing this, you use a test statistic that replaces the sample mean, x bar, with the sample proportion, p bar, and a hypothesized proportion, p0, instead of mu 0. The sigma squared in the standard error is computed by multiplying the hypothesized value times 1 minus the hypothesized value. In problem 7, we want to test whether or not a majority of Americans are aware of Quartz Computer Corporation's notebook computers. Now, majority of Americans is more than 50%. Now, the statement in blue is the alternative hypothesis. So the P here is the true population proportion. And if the true population proportion is greater than 0.5, then we can say that the majority of Americans are aware of Quartz Computer Corporation's notebook computers. Because the true population proportion cannot be known, we have decided to take a sample of 310 consumers. 0.461 or 46.1% of the 310 consumers surveyed said they are aware of Quartz notebook computers. So this 46.1% is the estimate of the true population proportion. Converting 46.1% to decimal form gives 0.461. The difference between 0.461 and the hypothesized value of 0.5 is the answer to the next blank. We're going to take the sample proportion, the hypothesized proportion, the sample size, and the alpha level. We're going to copy those values into Excel, complete the problem, and then copy the values from Excel back into Cengage Now. Before I do that, it's important to note that this is an upper tail test because an alternative hypothesis says P is greater than 0.5, which means the critical value is going to be positive. I've entered the sample proportion, 0.641, or 46.1%, the sample size, 310, the alpha level, 1%, and noted that the z-value will be positive because it is an upper tail test. Also, because of that, we divide the alpha by 1. When you have a one-tail test, you divide the alpha by 1. So we do that, we get 1%. The z-value is positive. We're going to find that value in either the standard normal table, but that only yields critical values of 2 decimal places. So we're going to get this in the infinity row of the t table. The t distribution table is found on my teaching website after you click on this link. And again, we can get the z critical value from the standard normal table, but we only get z values of 2 decimal place accuracy. So we're going to scroll through the t distribution table until we get to the infinity row, and we're going to be in column 0.01, alpha's 1%. In column 0.01 and row infinity, we get a critical value of 2.326. We're going to copy and paste that into Excel. Again, it's positive because it's an upper tail test. From the PowerPoint, recall that the variance of the variable in a proportions problem is computed in hypothesis testing by taking the p0 and multiplying by 1 minus p0. So the variance of the variable here is 0.5 times 1 minus 0.5. 0.5 is the hypothesized value. The point estimate of the difference between the population proportion, which is 0.461, and the hypothesized value, 0.5, is negative in this case. So there is a difference. The variance of the sample proportion is going to be smaller than the variance of the underlying variable, because the variance of the sample proportion is equal to the variance of the underlying variable divided by the sample size. The standard error of the proportion, or the standard deviation of the sample proportion, is equal to the square root of the variance of the sample proportion. The value of the test statistic is the point estimate of the difference divided by the standard error. All the values that we're going to paste into Cengage now were to 3 decimals, except the value of the test statistic was in 4 decimals, and the value of the standard error was supposed to be in 5 decimals. So I'm going to copy the standard error to 5 decimals into Cengage now. Then I'm going to grab the test statistic to 4 decimals and paste that into Cengage now. Next, I'm going to grab the point estimate of the difference to 3 decimals and paste that into Cengage now. The Z critical value for the test to 3 decimal places was 2.326. To conclude in part G, I need to compare the test statistic to the critical value. If the test statistic is greater than the critical value, we have evidence in support of the alternative hypothesis. However, that's not the case here. The test statistic is less than the critical value. So we have evidence in support of the null, which is the opposite of the alternative, less than or equal to 0.5. So because the test statistic is less than the critical value, we have evidence in support of the null hypothesis. So the null hypothesis cannot be rejected. If the null hypothesis can't be rejected, then we cannot say the alternative hypothesis is true. Thus, we cannot conclude that a majority of Americans are aware of quartz notebooks computers. We're going to check our work, and we should get all green check marks. And we do.